Hi Ash, let's consider all of these. Now, the play here is we are going to use the unit circle to help us find all of these angles, okay? So the unit circle, how it works is pretend we just have a circle with a radius of 1. So all around here is just 1 unit. And if we snap that to an xy axis, then we can come up with a bunch of numbers. This point here is going to be at the point 1 and 0. Up here is 0, 1, negative 1 and 0, and 0 and negative 1. And all of these angles in between can basically be found by, I'll try to draw this in, if you just drop like a straight line down and make a right triangle right here, a 30 degree, well this becomes a 30, 60, 90 degree triangle. So because of that, we can, the hypotenuse is 1 and we can find all sorts of angles. This 60 degree is the same deal. Only the 60's here and the 30's up here, and it's still a 90. Now, there's also a 45, which is not shown in this one. I just copied this from the internet, but that's where all this comes from. So what we're going to do here, because the hypotenuse is 1, it really simplifies all of our trig functions. Here we're asked to find the cosine of theta, and it's telling us that theta is somewhere in between 0 and 2 pi. So that tells us it's here on the unit circle somewhere. Now the cosine of theta is negative root 2 over 2. So let's have a look here along the unit circle, and we're looking for an x component where we have negative root 2 over 2. Sorry, actually I had a terrible unit circle without those values. So here's a better unit circle. Now you can see over here, right at this point, here's negative root 2 over 2 on the x component. And again, where that comes from is, if we just imagine for a second, if I make a right triangle, drop a line down here and make a right triangle right here, boom, boom, boom. Here's theta inside here. Now what we're trying to figure out, what's the cosine? And remember, cosine is adjacent over hypotenuse, but the hypotenuse is 1, so it's really just the adjacent side, which is really the x component. So there's negative root 2 over 2, and that corresponds to an angle of 3 pi over 4. And that's going to be our answer right there. So you just take it right from the unit circle. Nothing too fancy about that at all. Our next one, let's see if I can paste your second question in here. Yes. Let me tighten that up. There we go. And I'll erase all my mess. So this next one, same idea, but now things just get a little bit more complex. So here we're asked to find the value of this expression. Let's find out what the sine of pi over 2 is first. And again, we're looking at pi over 2, which is right here. Sine of that is going to be the y component. Again, if we were to make a big triangle here, right? So that's just going to be 1. Sine of pi over 2 is 1. Now the tangent of negative 21 pi over 4, clearly that's like a negative angle, and it's clearly way more than 2 pi, right? Because if I think about this, 8 pi over 4, just using the same denominator, get out of here, blue. 8 pi over 4 is 1 rotation. That equals 2 pi, right? I'm just building an equivalent fraction here. 8 divided by 4 is 2. So clearly that's not the case here. So let's find a coterminal angle for 21 pi over 4. And remember, that's just an angle that's literally at the same place, but of a different rotation. So if we want to think about it separately, we have negative 21 pi over 4. And I'm going to add 8 pi over 4, which is 1 rotation, right? So negative 21 plus 8, what's that going to be? 13. Negative 13 pi over 4, which is still no good, so we'll add another 8 pi to that. Just trying to save space here. Negative 13 pi over 4. And you can just do this to the side, or you can do it in your head, or however you want to do it. Now I'll add 8 more again. All right, so 6 and 8 are 14. So let's do negative 5, right? When we add 8 to that. Negative 5 pi over 4. Well, that's pretty cool. But again, let's just add 8 more pi again so we get a nice positive angle. So we'll do that. I'm just going to put in the negative 5 here. Now that's going to give us positive, what's that, 3 pi over 4? Come on, pen. 3 pi over 4. Okay, so I hope I didn't lose you there. I just added 2 pi 3 times to that, built out an equivalent fraction, and now this angle, 3 pi over 4, is basically at the same spot, but a different rotation, as negative 21 pi over 4 is. So now again, let's find the tangent. Instead of that mess, let's find the tangent of 3 pi over 4. We'll have a quick look around here. 3 pi over 4 is right here, and the tangent is going to be y over x. So anything divided by itself is going to be 1, but again, this is going to be a negative 1, right? Because that's going to come through. So that's going to simplify to negative 1. So a lot of brain work we went through just to come up with a super simple number. I'm just erasing some stuff. Feel free to skip ahead. So we've 1 times negative 1. Now we're going to minus that from the cosine of negative 11 pi over 3. Now again, let's just add an equivalent 2 pi, which is going to be 6 pi over 3. Again, because 6 divided by 3 is 2. We'll add that up. That's going to be negative 5 pi over 3, which is cool, but let's just add 6 pi over 3 again, and this is going to equal pi over 3. Right? So again, this is our coterminal angle, same angle. Let's find the cosine now of pi over 3. And we're laughing. So we'll find pi over 3 in the unit circle. We'll look at the cosine, which is the x component of that. Here's pi over 3. The x component is 1/2. So now we'll just do some order of operations. 1 times negative 1 is going to be negative 1 minus 1/2. I'm going to make that negative 1 an equivalent fraction. That's going to be negative 2 over 2 minus 1 over 2, which is going to be negative 3/2. So there you go. Simple fraction. It's all done. Again, just make this easy on yourself. Use the unit circle, Ash, and if you get crazy angles like this, just add or subtract depending on the situation. Add 2 pi as an equivalent fraction so that we can get a coterminal angle and then use the unit circle. Hope that helps.